All right, what we're doing is the configuration, or what we just did, was a configuration for bromine. And what we're learning about today is how to figure out a noble gas configuration. And so what I'm doing with this, what is this, pink? This arrow pink? Blue? Okay, well, some kind of a funny blue. Anyway, this arrow is going to be used for where we start our configuration. This arrow over here is going to be used to point out the element that we're doing the configuration for. So, scientists in general, as well as chemists specifically, are lazy. We are all lazy to some degree or another, and we want shortcuts to make our work easier. So, some brilliant man came up with the idea of doing a noble gas configuration. And because it's a noble gas configuration, it is, by the way, a very descriptive term, and we're going for noble gas configuration to replace the bromine configuration. So, what we do is we go up one row and seek our noble gas. The noble gas for all rows is right here in this column. And we always go one up to the noble gas, and then we start our configuration there. So I'm going to bring my starting point from here over to here. And now I'm going to go down and figure out, let's see, 3p, right? That's where argon ends, 3p. So what I'm going to do is draw a box around the noble gas, or the configuration for the noble gas argon. Now, what I can do when I'm writing the noble gas configuration, N-O-B-E-L, gas configuration, C-O-N-F-I-G for configuration. I write the symbol for the noble gas, and then I put a bracket around it. Oh, a lot shorter, because that, let's get another arrow here, just a moment. Okay. What we're going to do now is simply copy this part of the configuration, because that part always has to be there. That represents the electrons at the highest principal energy level. And so we go ahead and complete that. I'll do that in green to show that, yeah, we're rewriting it, but this is different now because it's in the noble gas configuration. And 3D10, but the numbers are no different. 4P5. And now I've completed the noble gas configuration for bromine, which has to start with argon. So here we have our noble gas configuration. Here we have the complete configuration for bromine. Yes.
Noble gas configuration again?
This is the noble gas configuration here.
Yeah, I know, but how to get that again?
Okay, what we did is we went to this guy.
Alright.
Okay, we figured out who the noble gas was on the next row up on the periodic chart from the element that we start with. So we started with bromine, and we went up one and over, and that gave us the noble gas that we need to start with.
So you do that every time? Do you just go one up and one over?
Well, if we were doing it for gallium, it would be 1 up and 5 over.
Oh.
It's just the end of the line. So, the end of the line. Yeah. So, the end of the line is where you're going, because that's where you get your noble gases. And so, we did this configuration first so you could see the savings in writing, not having to do the noble gas part of it. It's substituted by this. And that gets us on our way. Now let's do another noble gas configuration. I'm not going to do the full configuration for it because that'd be a lot of work. But let's go down and look at gold. Okay, if we were going to do gold, who would our noble gas be? Yeah, Xe. Okay, so we're down 2 rows. And Xe will be the start of our noble gas configuration for gold. So the noble gas configuration, I'll write this in a different color, for gold would be xenon and then we just configure, or then we just continue. Okay, so because we're starting with xenon, we would normally continue our configuration here, which is what we do in this case. So what do we have? 6s2, and how many in the 5D? 9. Okay, so 6s2 and 5D, 9. And that's it. That's a good deal, isn't it, huh? And if we're looking at the electrons that are going to be involved in bonding, then we would be looking at these guys right here. Because the S and P electrons are the guys that give us the bonding electrons for doing anything. And so as we look at S and P electrons, let's look up here. Okay, here's the P electrons. So if we were doing like fluorine, our S electrons would be here, 2 S electrons, and 1, 2, 3, 4, 5 P electrons. Well, what's our total? 2 and 5 is 7. Okay, and looky here, column 7. Remember during the test I told you how to do the noble, not the noble gas, but I told you how to do the configurations, not the configurations, come on, the valence electrons, there we go. Valence electrons always matched the column number, and so this column is 3, 4, 5, 6, 7, and 8 valence electrons, and we go across the valley here, and we go back here to find the other valence electrons, and in column 2 we have 2 valences, and in column 1 we have 1 valence electron. And that shows us how to get our valence electrons. And valence electrons are something that we're going to deal a lot with as we go on in chemistry. So let's do one more. How about uranium? Radioactive. Yeah, uranium. So what are we going to start with uranium? We have to go back and look. Okay, we follow it back, or follow it with this arrow. Here we go. Here's uranium, protactinium, thallium, and then we follow this arrow. Aha! We have the actinide series, don't we? Actinium is right here, and this is the actinide series, and it's labeled here. So actinide, actinium, and then we have radium and francium. So as we're going backwards from uranium, we can see that we wind up in row 7 of the periodic chart, which is the 7th principal energy level. Now, what's going to be the noble gas? Radon. Yeah. Radon is going to be our noble gas. So, we're doing uranium. We start with radon, and let's do that guy in black, Rn. And now we look at row 7, and what do we have in row 7 first? 7s2. And after that, what do we have? 6d what? Okay, now, look, we got 1, 2, here's our 3rd electron on this row, right? And that's where we stop and we go down. Okay, what I was just pointing to is we're starting here with the 7s, we go to actinium, and then we follow the arrow down and continue until we get to our element. Okay, so now you know what the number is, don't you? Yeah, 61. And then what do we have? 5, F, and that's going to be 3. And that's our configuration for uranium. Very simple compared to having to write the whole thing like we did with bromine. Okay? We have a pretty good feel for that? Everybody wanted to see one more, so why not? let's do arsenic. Arsenic and old lace.
Are you recording you now?
Yes, I am. And
Okay.
now, who's the noble gas?
Argon.
Argon, absolutely. So we're starting at argon and we're going to arsenic. So we're going to go down here and start it with argon. And let's see, let's do that. We did it with, is this black?
Yeah.
Okay, so argon. Do this guy in red. And as we look at argon now, we're going to start here at argon, and we're going to come on down a row and start on row 4, right? So we have, what's going to be next in our configuration? 4s2, yeah, 4s2, and after the 4s, what do we have?
3D10.
You bet, we got that 3D, and we go all the way over to zinc because it's full. Okay, so that's 3D10. And what's our last part?
4P.
Yeah, see, we go into the P's and we got 1, 2, 3 in the 4P. And so 4P3 is our last part.
Okay.
Now, here's the part that I'd like you to take notes on, and we're going to look at how to figure out the blocks. Oh my, they went away. Okay, let's go ahead and I'll redo those. Let's look at blocks now for just a second. Get these arrows out of the way for a minute. And I want to show you the S block, which we've done before, and the P block. Now, notice we have a 2 here on the 2P. We have a 2 here on the 2S, and we're on row 2. Everything is good. Life is easy. You're trying to figure out an electron configuration. All you need is the row number, and your S and P's are a piece of cake. So what I say with that is for S, which is columns 1 through 2, it's the same, you ought to write this down, same as the PEL, principal energy level. The P's, which are columns what? Come on, where's the P block? 3. Yeah, 3 to 8. And that is also the same as the PEL. No difference. So that part is piece of cake, no problem at all. However, what about when we get into this area? Down in the valley so low. Yes, down here. So, in this area, yes, I know I'm recording. So, for the whole wide world to hear. Yeah, you bet. Okay, here is our D block. Now, look at the numbers. 4S. Okay, we're going to stay on row 4, principal energy level 4, but, we have 3D. The difference between 3D and 4S is how many numbers? 1. Okay, take your 4, subtract 1, and that gives you your D's. Look, 5, subtract 1, 4. 6, subtract 1, gives you 5. And 7, subtract 1, gives you 6. So, that's what I'm going to put down here for the D's. For D's, that's columns what to what? Well, let's just call it D. For the D block, for the D block, what do we have? We subtract 1 to get sublevel number. Okay, so looking back here, for the Valley dudes, okay, the D block, everything is subtract 1 from the principal energy level, and that gives you the level of the Ds that you are filling. Now, for the F block, let's put a green block around this. For the F block, how many do we have to subtract? Look where the 4 goes. 4 comes up to here, and we're on what principal energy level? 6. Principal energy level 6. So, how do we figure out our F's? Yes, F block. Subtract 2 to get the sublevel numbers. Now you can take a periodic chart anywhere, and if you know just this much, you can write your electron configurations. Pretty easy, huh? Yes?
But for like the D block and the F block, you know how like the F block is kind of like between D block? So if you have like iridium or whatever, like.
All right, which one do you want to see? How about uranium?
No, I wanted to see one that was like in the D block, but.
Oh, in the D block.
6.
Oh, okay.
But.
You mean one that has the F's in it?
Yeah.
Okay. That would this row be good for you?
Yeah.
All right. How about osmium? Okay, good. So let's do osmium. Well, who's our noble gas? What?
Xenon.
Xenon. Very good. So we got our xenon dude, and we're going to start it with xenon. So for this configuration, we're going to be doing osmium. Okay, for osmium, the noble gas that we start with was xenon. Okay, after we get past xenon, we're going to go to where? See where we are? Okay, so we have the 6s with 2. And then we go across, and we've got lanthanum. Now, because we're going to go all the way across on the F's, see, because after we leave lanthanum, we got to come down here. So we're going to go all the way across, and I'm going to put that part of it in next, because it's mostly in that order. So we're going to call this 4F what? 4F14. And now we complete our D's. So as we look at the D's, we're starting at lanthanum. 1, 2, 3, 4, 5, 6. So we call that 5D6.
And like for one in the F block, you just count between the or whatever as a D, and then you do your F's.
Yeah.
So the order, like.
Yeah, I would normally want to do the F's first, and then put in my D's, because it mostly follows that order. Okay. Does everybody understand what we're talking about here? Yeah. Yeah. Okay. All right. So if we've got that, I think we understand how to deal with a situation where you don't have your periodic chart like this one with all the numbers in it that tells you what level is where. But now you know, once you have identified your S and P blocks, the D is very easy to identify, and the F is always down at the bottom. And most charts will give you these little arrows to show you who comes in where. And so that allows you to be functional. Okay? This little chart that I had you print last night is exceptionally helpful because it gives you kind of an overview of what the different principal energy levels are, the sub-levels that are within them. Okay, let's get us another arrow in. And so we look here at principal energy levels, sub-levels, and you'll notice you have a narrowing down as we go to, or an increase, I'm sorry, as we go from 1s to 2s, I'm sorry, principal energy level 1. Here we go. We have the 1s, that's all that's there. Principal energy level 2, we have the 2s and the 2p sublevels. Principal energy level 3, we have another sublevel. Principal energy level 4, we have a fourth sublevel. And that upside down triangle you're going to print for tonight is going to show you those 4. Okay? You're supposed to fill in that guy for principal energy levels 5, 6, and 7. So we also have here a comparison of orbitals. Orbitals represent how many of each type of orbital are in the respective sublevels. So, how many orbitals do we have in the 3D? I'm sorry, in principle, yeah. Yeah, the SPs, the Ps. The Ps on level 3. We got 3 orbitals. The Ps on level 4, we have 4 orbitals. The P's on level 5, we have 3 orbitals. The P's on level 6, we have 3 orbitals. We have 3 orbitals on all the levels where there is a P sublevel. All of the D's, they're the same number of orbitals. So if we have 5 orbitals, how many electrons can we have? 10, yeah. If we have 7 orbitals, we can have 14. If we have 3 orbitals, whoops, didn't need to move that. If we have the p orbitals, we have 6. Because there's 3 orbitals, we can have 6 electrons. And here we can only have 2 electrons because we're only 1 orbital. So this is very, very handy for you. And I think I already gave you notes on this, didn't I? Principal energy levels represented the distance from the nucleus. Yeah. Okay. And your sublevels represent the shapes of the orbitals that are in that energy level, that sublevel, and then the orbitals themselves, each of them containing 2 electrons, or possibly containing 2 electrons. All orbitals can hold a maximum of only 2 electrons. Here, I'm going to move this back so we can see the whole thing. There we go. Okay. And back up, and that can go back up. That's it, folks.